All right, so this is the next lesson we're going to be doing. It's actually lesson 10, but we're going to be building to this. So it's proofs using parallel lines cut by a transversal, okay? So what we're going to do is, our job is to either use parallel lines to show something is true, or given some information to prove that the lines are parallel. And we have to use, right, our geometry definitions and vocab to help us out here. So if we're trying to prove that two lines are parallel, we have to show that one of these 5 things is going to happen. We have corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, same side interior angle supplementary, or same side exterior angle supplementary. Okay. So when we draw the picture, right, we want to keep in mind that if we're trying to show corresponding angles, we need angles that are in the same position here. Okay. If we're trying to show alternate exterior, that they're switching sides of the transversal and switching intersections, okay? That if we're doing alternate interior, okay, we're taking the angles and we're doing the Z here. We're getting opposite sides of the transversal and inside. If we're doing same side interior, okay, that these angles are going to add to 180, all right? Or same side exterior, the same thing, that these angles are going to add to 180, all right? So let's see how this works. Now we're going to cross out this word congruent here, okay? And we're going to replace it with cut by a transversal. So if I'm given that two lines are parallel, so if we're given that the two lines are parallel, and we want to prove that other angle pairs are going to be true, we're going to want to use this statement right here, okay? All right, this statement right here. We'll draw a little box around it, all right? All right, so if two parallel lines are cut by a transversal, then, and we're going to insert one of these angle relationships that we just talked about right here, corresponding angles congruent, or alternate angles congruent, okay? If we want to prove the two lines are parallel, all right, then we're going to do this. We're going to state, okay, that if these angle pairs, alternate angles are congruent, corresponding angles congruent, okay, then the lines are parallel. All right, that's what we're going to want to state. So let's take a look at the first one. Now, we're given that angle 1 is congruent to angle 2. So to do a proof, to do any proof, the first step is to draw a T-chart, okay? So it's a big T down the middle, okay? And then the first side on the left, we put the word statements. These are statements, okay? These are things that we know are true, okay? Or can show are true. And we're going to put down reasons on the right. This is the definition or rule of geometry or algebra that shows that. Okay, we always start out any proof by listing the givens out. So we're going to say angle 1 is congruent to angle 2. And the reason for that first statement, no matter what, is always given. This is what we knew before we even started the question, okay? Now, after we put down the givens, we're always going to go mark up our diagram. We're going to label what we know is true about the diagram. We know angle 1 and 2 are congruent. Our job is to prove that L is parallel to M. We always end our proof with the proof statement. So how do I show that L and M are parallel? Remember, I have to get one of these 5 things here to happen. So in order to make this happen, I need one of these. And we already have it. We have the first one. Okay, these angles are corresponding. So since I'm trying to prove, that's this part right here, prove the lines are parallel, all I'm going to do is insert this reason right here. We're going to take number 2, and we're going to insert that reason right there, okay? So we're going to say, now the statement we want to say is just the proof statement. We're going to say L is parallel to M, and the reason, okay, is going to be right there. So if, and what do we have? If, right, the corresponding angles, we're going to use symbols whenever possible to cut down the writing, okay, are congruent. Remember, congruent symbol is the equal sign with the squiggly line on top. Then what had to happen if that's true, right? The lines, okay, have to be parallel. All right. Okay, when I drop down to number 2, Here we already know that the lines are parallel, so we want to show that one of these angle pairs is true. All right, so once again, we're going to start off with our T-chart. Top left is statements, okay? Top right is reasons. We always fill in the givens first. So the first statement is the givens. It's right here. We're going to say L is parallel to M. Okay. And the reason, this is reason number 1, all right, is going to be given. Okay. We're trying to show, so we know that this is congruent to this. We're trying to show that angle 2 is equal to angle 3. So how are those two angles related? Those are alternate exterior angles. And since we already know the lines are parallel because we just stated it in number 1, right, we can just say, now we can show that angle 2 is congruent to angle 3. And so our statement for this, okay, is going to be what we just marked down right here. All right, right there. All right, so we're going to say if two parallel lines are cut by a transversal, are cut by a transversal, okay, the alternate, and these are exterior, angles are congruent. All right. So for number 3, we're actually going to do a formal proof. This is just kind of like a, here's how you use it. Now let's actually do it. Okay. So first things first, got our statements and reasons, T-chart drawn. We're going to put out the givens. So we have QT, right? Line QT bisects angle PQS. And we also know that angle 1 is congruent to angle 4. So for reason 1, the first reason, we're always going to put down given. And we're going to go mark anything we know is congruent. We know angle 1 is congruent to angle 4. Okay? Now, when I'm doing a proof, if you look at your notes, this is the sheet you guys got, and you turn it to the second page. Okay? We start with the T-chart, statements and reasons, fill in the givens but given. We're going to label any congruent sides or angles. We already did 1, 2, and 3. Number 4 is we're going to look for any keywords, anything like midpoint, right angle, perpendicular, bisect, any one of those things. That's going to help us make any new statements. Then we're going to look at the diagram and then you look for any new statements. Do you see any straight lines, vertical angles, any shared sides or angles? We'll get there a little bit in the future. And your last statement is always the prove statement. Okay, so going back, we see a keyword bisect. So what does bisect mean? You guys remember? Cut into 2 equal parts. This is what's being bisected. So if I said I bisected a watermelon, that doesn't mean that I got cut in half. The watermelon did. Whatever follows the word bisects is getting cut in half. So angle PQS, which is right here, okay, is getting cut in half. If we cut that angle in half, that means that angle 1 is going to be equal to angle 2. So the statement we can make now is that angle 1 is congruent to angle 2. Okay, that's a new statement. So we know that that's true, and we have to give the reason, right? And the reason was the angle bisector, okay? Angle bisector, okay? Cuts angle into 2 congruent angles. Now, if you wanted to use your notes, okay, we would go for angle bisector, and we also could put down definition of angle bisector. But what I'd like to do with you guys to start off with is using that word bisector, just explain what it means here. We're cutting it into 2 equal angles, okay? All right. Now, we still have to show that the lines are parallel. We have to get one of those angle pairs to happen, right? We need alternate interior, alternate exterior, okay? Any one of those things. And if you're looking at the line now, we just shown that these 2 angles on the Z are congruent. Well, actually, we didn't do that yet. We want to show that 2 is congruent to 4. And since 1 and 4 are equal, and 1 and 2 are equal, what we're going to do is we're going to take this angle 4 and we're going to place it in where angle 1 is. We're going to substitute it in. We're going to swap it out. Okay? This is actually called All right, the transitive property. All right, the transitive property. And I'm trying to think if it's on here. Well, we'll add it in. All right. So for number 2, the next statement we're going to write, actually number 3, we're going to take out number 1 and we're going to put angle 4 in its place. Angle 4 is congruent to angle 2. Okay. So the reason why two things are equal to the same amount, they're equal together, is called the transitive property. Sometimes we'll use substitution, which also works here. I'm taking angle 1 out and putting 4 in the spot. Okay. And now we actually have enough to say that these two lines are parallel because I have these knees, right? I can't actually use these knees, but it's alternate angles congruent. We're going to finish off with our proof statement. QT is parallel to RS. All right. And the reason is going to be, you guys remember? If, what do we have? Okay, the alternate. I'm actually going to type it so you guys can read it a little better, okay? So, if alternate interior angles, wrong way, angles are congruent, okay, there's a congruent symbol, we'll use it here. Pardon me while I get them in there, okay? And the lines are parallel. And we're done. We ended with the proof statement. That's it. We're done. All right, let's go to the next page. We do the same thing here. We want to show that these two lines, okay, BC and G and GF are parallel, okay? We're trying to show that this line here is parallel to this line. So we need to get one of those angle pairs to happen. So first things first, okay? We're going to put down our givens. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 1, and the reason is given. Okay? Now that we marked a diagram, remember step 2, okay, is to fill in the givens and then mark your diagram. So label any congruent sides with dashes and angles with arcs. Okay? So if I know angle 1 is congruent to angle 2, I'm going to draw an arc on those two angles. If I know that 3 is congruent to 1, I'm going to put an arc on those two angles. I already have one there. Okay? My job is to get those lines to be parallel. So one thing we can do is to get stuck, okay, is to work backwards from the proof statement. What do I need to show to make that happen? So if I want to show that these two lines, BC and GF, are parallel, I'm going to need to get some of those angle pairs congruent. And these two angles are key, 3 and 2. If 3 and 2 are equal, those are corresponding angles, then the lines are going to be parallel. Now remember, I already know that 1 is equal to 2 and 1 is equal to 3. So remember we talked about in the last question. That means we can use the transitive property to show that angle 2 is equal to angle 3. Okay? And we're going to put down transitive property. Okay? All right, and now that we have angle 2 congruent to angle 3, we can prove the lines are parallel. So we can say BC, line BC, is parallel to GF. Right? All right. And the reason is going to be, okay, if, what do we know? 2 and 3 are corresponding. So if corresponding angles are congruent, we know then the lines are parallel. And that's it. Okay? The last question we're going to do involves what's called Euclid's parallel postulate, okay? This is our Euclid's parallel postulate. This is what we're talking about when we draw an auxiliary line. All right? So if you're using an auxiliary line, you're going to use this as our reason. That's the reason for the auxiliary line, okay? So if we're trying to show that angle Z is equal to x plus y, that these two things are equal, all right, we're going to use an auxiliary line. So first thing we're going to do is our t-chart. Okay. Let's go down a little bit here. So we're going to put statements on the top left. All right. Reasons on the top right. And we're going to fill in. So 1, the first statement, AB is parallel to CD. The first reason is always given. All right. And now for step 2, we're going to draw in our auxiliary line. So I'm going to take, maybe. All right, and draw in this auxiliary line right here. Okay. It actually needs to go through Z. Oh, don't break it. All right, so I'm going to move this up just a little bit. Perfect. Okay. And let's call it something. Okay. So let's call this EF. All right. All right. So for a statement, we're going to write down draw EF, line EF. And for 2, we're going to write Euclid's parallel postulate, which basically says, okay, if I have a line, there's only one line that can go through a point, okay, that's parallel to the original line. And that's all we're doing. We're drawing a line through points, through the vertex that's parallel to the lines there. Okay? So draw a line EF, all right, parallel to, we'll actually add this in, parallel to CD. Okay? So for number 3, now we're going to do some work. All right? And let's call this 1 and 2. We're going to name these angles 1 and 2 so we can reference them, okay? So for now, first part, we need to say, remember, now that we know the lines are parallel, because we stated with the postulate, we can show that this angle X is congruent to this angle, which we're going to call number 1. Okay, so we know angle X is congruent to angle 1, and we know that this angle 2 is going to be congruent to angle Y. Okay, angle 2 is congruent to angle Y. Remember the reason, okay? So we know the lines are parallel, so we're going to start with if two parallel lines are cut by a transversal, then the alternate, or actually not alternate, corresponding angles are congruent. All right. Now we still have to get X and Y to add to Z. And that works because of what we just did right here with our auxiliary line. We cut that angle together. So for 4, we want to say that angle 1 plus angle 2 is equal to Z. All right? And the reason for this, all right, if you look in our proof notes, all right, is called angle addition property. Let's see it. Find it. Hold on a second. We'll pause it while I find it. It's right here. Angle addition, okay? So I can add 2 angles together to form a bigger angle, That's called angle addition property, okay? So we're going to write down angle addition property. All right? And then for 5, we're just going to swap out. Remember, 1 is actually equal to x. So we're going to say angle x, right? Or just x, okay? Plus angle y is equal to z. And that's just substitution. We're just taking something and putting it in its place. And this is our proof statement. So that's it. We're done. Okay? And that's it. Hopefully that went okay. If you have more questions, we'll do some more of these in class. So bring this worksheet with you and have a great weekend, guys.